This is the first new city made in America in, I think, quite a few decades. At least that's what I'm told. And a very cool name. And it's named that because it is where we're going to develop the technology.
What's next for humanity? Elon Musk just dropped jaw-dropping predictions for 2026 that could change everything. From building a new city in Texas to colonizing Mars, his vision is nothing short of revolutionary. In today's video, we'll dive into Musk's ambitious plans, the cutting-edge tech fueling this future, and what it all means for our journey as a multi-planetary civilization. Buckle up, because the future is arriving faster than we think. Let's get started. Musk begins with an inspiring recount of the transformation of a previously barren sandbar in South Texas into a burgeoning spaceport and manufacturing hub known as Starbase. Just a few years ago, the site was nothing more than an empty stretch of land. Today, it boasts 2 colossal launch pads, a state-of-the-art rocket factory, and infrastructure capable of supporting frequent launches of the massive Starship spacecraft. What makes this development extraordinary is its accessibility. Musk emphasizes that anyone can visit Starbase, drive along the public highway and see the rockets up close. This openness marks a significant shift in space exploration, moving from secretive, heavily guarded facilities to public, transparent hubs of innovation. Such accessibility is intended to inspire the public, foster education, and democratize space progress. Starbase has already achieved tremendous milestones. Musk proudly reports that the facility can now produce a Starship every 2 to 3 weeks. Although not yet at the ultimate goal of 3 ships per day, this rapid pace signifies a monumental leap forward in space manufacturing. The vision is to expand production capacity to hundreds or even thousands of ships annually, enabling humanity to establish a sustained presence on Mars and beyond. The gigantic scale of SpaceX's manufacturing and launch infrastructure. Musk describes the construction of enormous structures, some of the largest in the world, designed to facilitate the mass production of starships. The Gigabay facilities in Texas and Florida will serve as the backbone of this effort, capable of building and processing 1,000 ships per year. When compared to traditional aerospace giants like Boeing and Airbus, SpaceX's scale becomes even more apparent. Musk suggests that SpaceX could eventually produce as many Starships as Boeing and Airbus produce commercial airplanes combined. Each Starship is an engineering marvel, bigger than a Boeing 747 or Airbus A380, and capable of carrying payloads that will revolutionize interplanetary transport. The ships will ferry not only humans but also essential equipment, supplies, and infrastructure needed to establish self-sustaining colonies on Mars. The power of Starlink and satellite deployment. Musk's ambitions extend to satellite technology as well. The new Starlink Phi-3 satellites, each roughly the size of a 737 aircraft, are being produced at a staggering rate, up to 10,000 per year in the future. These satellites will provide high-bandwidth internet even across the vast distances of space, enabling real-time communication with Mars and supporting the logistical backbone of humanity's extraterrestrial civilization. This satellite network isn't just for connectivity, it's a critical component for supporting Mars colonization efforts. Reliable, high-speed internet will facilitate remote operations, scientific research, and even entertainment for future Martian inhabitants. Musk envisions a future where Starlink becomes an essential infrastructure element for interplanetary civilization. Scaling up, from Earth to Mars and beyond. Musk stresses that achieving a multi-planetary civilization hinges on the development of rapidly reusable rockets, vehicles that can return to Earth, be refilled within hours, and fly multiple times per day. SpaceX has pioneered the concept of catching rockets mid-air with massive robotic arms, an engineering feat that drastically reduces turnaround times and costs. The goal is to make rocket landings so efficient that boosters can be refueled and redeployed within an hour, significantly lowering the cost per launch. This rapid reusability is fundamental to Musk's vision of making space travel accessible and economical enough to support millions of people traveling to and from Mars. The revolutionary Raptor 3-engine and orbital refueling. Central to this effort is the development of the Raptor 3 engine, an advanced propulsion system that promises unprecedented efficiency, reliability, and simplicity. Unlike traditional rocket engines, the Raptor 3 eliminates the need for complex heat shields during re-entry, thanks to innovative design features that can withstand the intense heat of re-entry into Earth's and Mars' atmospheres. Another groundbreaking technology Musk highlights is orbital propellant transfer, akin to aerial refueling but in space. By transferring fuel and oxidizer between ships in orbit, SpaceX can extend the range and payload capacity of Mars-bound ships, making interplanetary voyages more feasible and economical. Musk envisions demonstrating this technology within a year, a critical step toward establishing a sustainable supply chain for Mars missions, overcoming the challenges of reusable heat shields. One of the most technically demanding aspects of Mars colonization is developing a reliable, reusable heat shield capable of surviving multiple re-entries. Unlike the Space Shuttle's tiles, which required months of refurbishment, Musk's team aims to create a resilient shield made from advanced ceramics, glass, and carbon composites. Testing in simulated Mars atmospheres, rich in carbon dioxide, reveals the complexity of designing a heat shield that can withstand the higher oxidative environment. Musk emphasizes that the same heat shield materials tested on Earth should be effective for both Earth and Mars, provided they undergo rigorous testing and iteration. Building the next generation Starship, longer, taller, and more capable. Musk discusses plans for a second-generation Starship which will be taller, more efficient, and capable of carrying larger payloads, up to 4,000 tons. The new design features an improved interstage, better hot staging capabilities, and a sleeker, more aerodynamic profile. These upgrades will increase thrust, payload capacity, and reusability, bringing Musk's vision of a multi-planetary civilization closer to reality. The new starships will be equipped with 42 Raptor engines, an homage to Douglas Adams' Hitchhiker's Guide to the Galaxy, where the answer to life, the universe, and everything is famously 42. This number symbolizes the scale and complexity of Musk's ambitious engineering project, aiming to develop the most powerful and efficient rocket ever built. Timeline and milestones from 2023 to 2030 and beyond. Musk projects that by the end of 2023, SpaceX will conduct the first launch of the upgraded Starship with the new Raptor 3 engines. The goal is to demonstrate rapid reusability, orbital refueling, and interplanetary transfer capabilities. By 2024 to 2025, the focus will shift to scaling up production, testing orbital refueling, and refining heat shield technology. The critical window for Mars missions opens every 26 months, with the next opportunity at the end of 2024 or early 2025. Musk remains optimistic that, with successful testing and infrastructure build-up, the first uncrewed Starship could reach Mars by late 2024 or 2025, paving the way for crewed missions shortly thereafter. The long-term vision: establishing a self-sustaining civilization on Mars. Musk's ultimate objective is to create a self-sustaining city on Mars, an independent civilization capable of thriving even if Earth's resupply missions cease. To achieve this, Musk estimates that about 1 million tons of infrastructure, supplies and equipment will be needed to build a resilient colony that can support thousands of residents. This involves deploying multiple ships per launch window, establishing a network of landing pads, and developing local resource utilization, such as mining water ice and producing oxygen and fuel from Martian materials. Musk envisions a Battlestar Galactica scenario, where hundreds or thousands of ships orbit Mars, ready to land and support a burgeoning civilization, reimagining humanity's future, from science fiction to reality. Musk's predictions are not mere science fiction, they are grounded in technological advancements already underway. The development of reusable rockets, orbital refueling, advanced materials, and autonomous robots like Tesla's Optimus are all critical pieces of this puzzle. He also emphasizes that Mars colonization isn't just about exploration or survival, it's about creating a new chapter for human civilization. A multi-planetary existence would dramatically increase our chances of long-term survival, protect against planetary disasters, and open up vast new opportunities for science, industry, and culture. An unstoppable journey toward the stars, Elon Musk's visionary roadmap for 2026 and beyond paints a picture of bold progress and relentless innovation. From the sprawling spaceport in Texas to the red sands of Mars, his plans aim to turn humanity into an interplanetary species. The technological hurdles are formidable, but Musk's track record shows that with ingenuity, perseverance, and a dash of audacity, what once seemed impossible is now within reach. As we stand on the brink of this new era, the question isn't just about the technical feasibility, but also about the profound implications. Humanity's future among the stars could herald a new age of exploration, resilience, and civilization building, an epic journey that Musk's vision is propelling us toward with unprecedented speed and determination. The next chapter of human history is being written now. Are we ready to take the leap?